Chad Sakac. I am a nerd. My job at EMC is I'm Mr. VMware. Officially, I'm the VP of the VMware Technology Alliance. I author a blog, Virtual Geek. More than anything, I love VMware. I love our technologies together. I love what's going on in the industry. Like, how can you not be blown away by Mr. Herod's keynote? That was pretty cool. So, I'm going to try to replicate that coolness in this session. We're going to cover a lot of territory, so I'm going to do it relatively quickly. Just out of curiosity, how many people here are EMC customers? Right, thank you. Raise your hand if you're not an EMC customer. All right, fantastic. Hopefully I can do some persuasion as part of this process. But how many of you are VMware customers? Thank you so much. On behalf of both companies, guys, the customers make the world go around. You steer our roadmaps. Hopefully we're serving you as best as we can. So what we're going to try to do in this session is we're going to be talking about next generation storage and backup. I've tried to keep this relatively advertising free because I know that that's not really what people want in these sessions, right? What we're going to talk about, big idea, and then we're going to give some examples first around backup about what we're doing today and what we're doing tomorrow. And then we're going to do the same thing on storage. How many of you were in the EMC Super Session? Just out of curiosity. Okay. One thing that Pat Gelsinger, our CEO, set up was this idea of disruptive technologies drive lasting change. What this means is like there's certain waves of technology that come along where everyone in the world, whether you're a customer or a vendor, has to just deal, right? You've got to roll with it, you've got to adapt. If you don't adapt, it'll eventually roll right over you, right? And virtualization and VMware is probably the biggest disruptor to the market, along with commoditization of x86, emergence of flash, commodity, 10 gigabit Ethernet, all sorts of stuff like that. So in backup land, what are the core state-of-the-art technologies today? If you're a backup vendor, what do you need to do? Well, so you need to be able to leverage virtualization to be able to do backup and recovery faster. Step one, right? So in the virtualized context, there's a lot of tools and APIs that you can leverage, right? So you can use change block tracking, which emerged in vSphere 4.1, and it's actually got a few little improvements in vSphere 5 to reduce the amount of data that needs to be deduped and backed up in the first place by letting VMware tell you. If you stop and think about it for a second, that means that VMware is helping give new options for backup that didn't exist there before, right? Likewise, all of the vStorage APIs for data protection that allow you to not have an agent inside the guest. Agents suck in general. People don't want to have agents, right? Now, there's still times where you need agents if you want to have application integrated backup and restore scenarios. But for every one host and every one VM that you have that's like that, you have hundreds where, you know what, if you do instant file level restore, that's good enough, right? It simplifies the amount of agents. The other things, that are important is being able to do this can accelerate your adoption of virtualizing the things that matter. How many people here have virtualized their SAP environment, SAP landscapes? So, going to Oracle, SQL Server, SharePoint. And so you can see there's laggards, leaders in terms of individuals, companies, but also these. Gotta tell you, if you're not getting the memo, you can virtualize mission-critical applications with confidence. But a big part of that is how you do backup and recovery. Can you do it at the time you need? Can you hit the RPO that you need? The third area, which is the emerging area, is vCloud directory use cases. So, does anyone here use VCD? Right? VCD backup is tricky. We're going to be talking about what we're doing today and tomorrow around that. So, the thing that I wanted to highlight is the power that you get from the vSphere storage APIs for data protection and change block tracking is dramatically faster backup, right? By basically using the CDT, we were able to back up 1,000 VMs, 50 terabytes in around 43 minutes, right? Now, you can see it took a little bit longer during the ramp up, and then what does it look like in steady state? This is using Avamar 6, which is also tightly coupled with vSphere UCs. The other thing that's cool is that Avamar uses change block tracking also during restores. So when you're doing a full VM restore, the full VM restore can happen very, very quickly, very rapidly, which we're leveraging it quite uniquely in both directions, which is cool stuff. So by doing that, you can basically go through the proxy and very rapidly, you can restore a huge 100 gig VM in a few seconds, depending on the amount of data that's in the CVT set of change blocks. Now the other thing that's going on in VMware land, if you're using a backup tool, do we have any VMware customers, by the way, in the room? How's it going? Great. Question, anyone not happy? The product team, where are you? Go and talk to them, right? If you want to hear roadmap, feedback, they want to hear from you. So go and reach out to them. But thank you. And in general, people love Avamar with VMware. One of the reasons is all this stuff I talked about, but the other one is loads and loads of vCenter integration, right? There's still more that I think we need to do on that front, speaking quite frankly, right? So we do a really good job of integrating with vCenter from the bottom up. So if you're using Avamar, you can see what VMs have been backed up, when and how. Right, whether it was full VM, whether it was an agent and a guest, whether it was both. You can see you can drive back and restore. You can mass enable change block tracking, which is cool. We could probably do more to integrate into vCenter so you can trigger restores and things like that from within vCenter directly. But I think we're leading the way even today on vCenter integration with Avamar 6. Now again, I don't want this to be an Avamar commercial. These are technologies for which every backup vendor really needs to get on the train and start growing. So again, raise your hands if you're an Avamar customer. For the people that didn't raise your hand, I'd highly recommend finding someone to raise their hand and ask them, I'm using blank. You're using Avamar. How's it going? How am I going? You'll find that these technologies make your life better. You can virtualize more faster. Right? So, the other thing that's important is dedupe is now a mandatory thing. Again, this is something where it doesn't matter whether you're EMC, whether you're somebody else. If you can't do dedupe, something is wrong with you, right? So the thing is, dedupe comes in different flavors. There's source-based dedupe and target-based dedupe architectures on the market for backup use cases. And then there's primary source deduplication use cases as well. So the point here is that Avamar uses a source-based approach, which is really good when you're trying to reduce contention at the VMware layer. But sometimes there's times where source-based dedupe isn't that great. When you're trying to back up a single VM that has a gigantic database on it, where you need to do lots and lots of throughput really fast. So for a while that was a problem for us because we had to do one or the other. You could use data domain, the best target, or Avamar, the best source-based dedupe. Well, so what we did is we made it so we integrated the two, so you can basically say these VMs, these thousands of VMs or hundreds of VMs, can have agentless-based backup, great, with source-based dedupe, with VADP and change block tracking, all that cool stuff. And for that one or two VMs, that's a massive monster VM, like you've been hearing about for the last 2 days, right? That one can go directly using data domain boost directly to a data domain target. Very, very high, in fact, the world record speeds for dedupe backup targets. Cool stuff. Now, lots and lots of great customer examples. We thought, we're in Vegas, so why not use a Vegas, Hard Rock Hotel Casino. I don't know if they're here actually. Are they here? I'm curious. No? Alright, well, I didn't ask them in advance, so that would have been kind of cool. But, basically, tons and tons of customers who are using Avamar are finding that they're finding things better, faster, sped up through the process. Now, yay, we're great. And I do think our stuff is awesome. So what's the next step? Because we leverage all of that stuff, that's the today. So what's the tomorrow? The tomorrow is we're getting lots and lots of requests, more every day, to be able to do multi-tenant, cloud-based backup and restore and backup as a service, right? Whether you're an enterprise or a service provider, and more customers are using vCloud Director to do that. The challenge is if you want to do this, you've got to be able to do all of these little piece parts. Because when you use vCloud Director, there's the VCD database, there's constructs that exist within vCenter, which are resource pools that have really long, funny string names. And then there's the catalog, and then there's the virtual machines, and then there's the whole structures of tenancy, right? You need to be able to do each one of these things to be able to do it. And so we had a few service providers first come to us, where's Zola in the room? Who came and said, guys, we need to solve this problem. And we were like, okay, we'll try. You're our customer, we're going to do our best. And we built some great solutions out of that, where Avamar can do each one of these things. But it involves a lot of Mike traveling around and making it work, right? Scripting and integration. So we said, let's make it a little easier on them. We wrote a great white paper that says, here's how it works. And we can integrate it and make it work today. Fantastic. But there is a better way, right? The better way would be if we could build it into integrated product and capability. So again, who uses VCD? Raise your hand. This will be interesting to you, and to anyone who's not, you're going to be using VCD soon enough. It's going to be the predominant way that people interact with VMware going forward. So check this out. So this is a preview, technology preview of something that we're calling vCloud Protector. So as you log in here, what's interesting is this directly goes into the same credentials that you use for VCD. So if you're an administrator, you're an administrator. If you're a provider, you're a tenant level admin, you're a tenant level admin. And what this does is it reflects the VCD UI because this actually uses the vCloud Director APIs to pull all that information. So you can see provider virtual data centers and then organizational VDCs, right? If I switch over, this is actually the VCD instance. Look, hey, not only does it look the same, but it has the same structure because, hey, we're actually integrated these things completely at the API level. Make sense? So if we take a look and we go back over to vCloud Protector, you can see that we've got the provider VDCs and we've also got this data protection policy. When you click on this, you can see these are the policies that have been set up. And again, as we continue to develop this product, you can further customize them and build them. The core idea here that's important is that when you're operating at these cloud scales, which doesn't necessarily mean a huge service provider, it could be any customer, where stuff's happening all the time, you need to have trickle-down policies. So what we said is, let's make those data protection policies, you apply them at the organizational VDC level, and they'll trickle down to any VM that's created within that org VDC. So for example here, we've got an example, the Dinoco example, right? And I'll go into that one in a little more detail. At the provider VDC level, you can see the ones that this provider VDC, which is like a resource pool, is allowed to have. So we've got the classic bronze, silver, and gold. And if you click on it, you can say, hey, here are the two customers or the two tenants that are using that bronze policy. You could go in and you could customize that policy. You can change the backup process, which is fantastic. Right? So you can go and say, yeah, they're going to inherit anything subsequently within this. The VMs, the catalog, items in the catalog that they create, are going to apply against these. So the example that we thought would be kind of interesting, right, is to take a look at this one customer. So if you click on that one customer, these are their individual vApps. Again, this is linking into VCD, so it looks the same and it's integrated, which is what people want. It makes it simpler. So if we take a look at them, you can see is the policy on or off. What's the policy name? When was the last successful backup? How many backups do we have? And so on and so forth. Right? So if we take a look at one of the individual VMs, you can see that there's been a series of backups here. They've been successful. They occurred very rapidly. You could go and you could change this for the individual VM if you want, but again, it inherits the backup. So backup becomes part of the service layer. It's backup as a service, right? And here I'm going to go in and say, okay, this individual VM needs something that's slightly different. We're going to set it up with a bronze SQL Server policy, and off it goes. Now, of course, periodically you want to do an on-demand-based backup, right? So in the example here, what we did is we said, okay, let's go over and take a look. Here again, we've got our core structure. There's the VM down there. You see the blue one that's running. That's a Windows 2000 VM. And if we go and we take a look, let's say I want to do an on-demand backup. So I'm going to install something, I'm going to patch something, so on and so forth. Again, it's awesome to use the vSphere snapshots for that. It's great to use array integrated snapshots, which EMC totally supports today. And generally, those can augment backup policies. They're not so good when you want to retain it for long periods. So what I just did is I did a backup. It was fast. Why? Change block tracking, source-based dedupe, right? I fast forward a little bit in time. We created a blue screen event to say, hey, look, something bad happened. So, obviously what you want to do here is you go back in and say, I want to go back to that earlier point in time, and I want to be able to do a restore, an on-demand restore. And when you go this process, it's going to overwrite that individual VM because we're doing a full VM restore. And again, we're going to leverage all of the great integration that we do today around change block tracking, source-based dedupe, vCenter integration, VADP, all that stuff. But again, leveraging it here in this multi-tenant cloud backup as a service type model. Does that make sense? See some nodding, some like, okay, all right. And if we come back, boom, VM back up and running. Does that make sense? What do you guys think? Is that a good idea? Good idea? Who says yes? Yes. Remember, technology preview. You can't get that today. I don't want to set anyone's expectations stuff. But believe it or not, that, as cool as it is just the tip of the iceberg. There's a lot more, and they come up running on stage right now if I said another word, strangle me. She's not even. All right, so let's shift over a little bit to storage. So now on the storage side, there are also mega trends, disruptors that are affecting everybody, right? And they look something like this. They're all about fundamentally dealing with the deluge and huge growth of information. So being able to contain costs, become more efficient, right? Now when I say storage cost, it's dollars per
gigabyte.
Dollars per gigabyte, right? Well, maybe not. Maybe it's dollars per IOP, right? Maybe it's how much does it cost when I need to do an unplanned change, right? Those are all units that are real measures of cost. And it's not just dollars, it's watts per, right? U per, right? All of those things are efficiency technologies. In general, in vendor land, and I'll include us in there too, each one of us has certain cool things that we do in some of these technology areas. And every vendor tries to make it sound like that's the one thing that you've got to have that will make you efficient. The reality of it is, it's all of these things collectively together. And they're affecting everybody in storage land, right? So, examples. Dense storage platforms. You know, our latest state-of-the-art is we can fit 30 spindles, 60 spindles in a 4U footprint. That means we can fit 1.8 petabytes raw into a single cabinet, right? That is very important if you're a service provider. You need lots of capacity in a small space, right? There's also these huge 3 terabyte spindles. There's thin provisioning, dedupe, compression, all these things, right? And then down the performance side, who here uses an SSD in their laptop? A solid state disk. By the way, you gotta love VMworld, nerdy crowd. That's a higher ratio than I see normally. So, hey, me too. Right? Would anyone who raised their hand give it up? No? Why not? Because it's so much faster. Not a little bit faster. It's face-meltingly faster. Right? But you wish it was a little bit
cheaper,
bigger, right? So the thing is, if you think about it, when we launched SSDs, which we've been doing now for 3 years in the enterprise use case, so it's not something new for us, we started by saying 30 times faster, but 10 times more expensive. Right? Which means everyone goes, okay, I need to find something where 10 times more expensive per unit gig is worth it to me, right? What we should have said was, same performance, 1/3 the cost. Through Penn and Teller-like use of mathematics. Maybe that sounded a lot better, right? So the point there is, it's an efficiency technology, and it was a long time ago when you looked at dollars per IOP. Right? It's actually slowly starting to catch up, even in dollars per gig. It's still not there, but there will come a point where it will be. It's already about 100 times cheaper measured dollars per IOP, and about 3 to 5 times more expensive when measured dollars per gig. So what does it mean? It means that today technologies like auto tiering are really, really, really important because you want to be able to leverage both, right? And storage DRS, right? Policy-driven storage, all those ideas. What no one thinks about in terms of economic value is the blue line, which is basically the cost of unplanned change. So what I'm going to try and encourage you to think about is that the red line is how can I deal with the deluge when it comes to lower my dollar, power, and space per terabyte, right? The green one is how can I keep lowering my dollar, space, power, cooling per IOPS or per megabyte per second. And this one is, how do I make storage invisible so I don't need to spend as much time dealing with it, right? Because it's pain. So, what are we doing down each one of these fronts? First down the invisibility front. So this is VMware integration circa 2011. In other words, right now. The blue stuff is stuff that VMware has, and this orange is storage railing. And this isn't an EMC picture, this could apply to any storage vendor. So, you can create plugins into vCenter that makes it easier to provision. You can make your array VM object aware, where it starts to speak to vCenter, show vCenter stuff inside the UI, right? You can build something that changes or improves the multipathing policy for how vSphere and vSphere 5 operate. Right? You can leverage those vStorage APIs for data protection, for backup, as well as array-based snapshot mechanisms. You can obviously use SRM5 and build an SRA, storage replication adapter for it. You can build a VAAI, the vStorage API for array integration module, right? And there's changes in vSphere 5 when these move to standard T10 commands as opposed to needing vendor plugins, which is good. So you can, the bad way of doing it, or the earlier way of doing it, was to build plugins that ran on the vSphere host. Now vSphere 5 has moved to a standards-based model. There's now vSphere 5 NFS VAAI commands. The array vendor can implement it down in their part of the stack, and then they need to write a VAAI NFS module. And then the last thing in here is this VASA module. This is a lot of engineering work, right? There's a whack load of engineers at EMC that work hard every day to make sure that we're doing everything we can to be first and best for you guys on all of these fronts. But these are things that everybody can leverage and everyone should leverage. So, by the way, there's also cooperative development that happens high up inside the VMware stack, where we work hand in hand with the VMware engineering teams. Has anyone noticed anything when they went to vSphere 4.1 and used VAAI stuff on their array, just by a show of hands? Anyone? Was it generally positive, negative? Very positive. What did you see? Faster? Faster, right? Yeah. Anyone else? In general, the feedback was awesome, right? There was a lot of changes. So, what people found is they found that storage vMotion operations would occur much more rapidly. Clone and deploy operations would occur a lot more rapidly. And that way less stuff would be used on the network and on the ESX host and storage array. Now, we learned lots of stuff also through that experience. There was like, how do we test, how do we qualify, and VMware and EMC have hardened that entire process as we go into vSphere 5. And speed of operations and some of those things, I did a webcast on this topic. So I'm a firm believer that EMC has got a responsibility to you guys to be as transparent as we can. Good, the bad, the ugly, right? So workarounds, those sorts of things, I'd encourage you to check out that one. Now, what has changed in vSphere 5? In vSphere 5, the block assists, there were 3 of them, right? Hardware accelerated 0, hardware accelerated copy, and atomic test and set, which is this hardware accelerated locking. So there's no longer a locking problem with, how many VMs do you have on a data store. They moved, like I said, to a T10 compliance model, which means it's easier for the storage community to have a standard way of doing it. But we introduced some new stuff too. VMware introduced some new stuff. Thin provision stun. Is anyone here using thin provisioning? You should. It saves you a lot of money. But there's some hazards that go along with it. You need to monitor space at the VMware layer and the storage layer. Because without this API, as you fill up the storage pool, eventually what happens is it goes, hey, wait a second, I just ran out of 3 blocks in the pool, and a write fails, at which point you start to get a lot of weirdness at the VMware layer, right? With the API instead, it sends a separate thing that says stun the VMs. The VMs, you get a little pop-up in vCenter that looks like this. You can expand the pool and then continue. Make sense? By the way, this was kind of in vSphere 4.1 and we support it, so it's already in the firmware from EMC, whether it's our mid-range or high-end arrays. There was something else added too, which is thin provision reclaim. So the idea here, right, is that without the API on a block device using VMFS, you'd create a file and it would write data on the pool. If you wrote another file, it would, add more stuff in the pool. And at the end, if you delete a file, it wouldn't actually free up the space at the storage layer. Right? You need to manually go in and reclaim the space. What's changed is we're leveraging this SCSI unmap, a standard command, to instead go, hey, I'm going to write a file, I'm going to write a file. When I delete a file, I'm going to do this unmap, which frees the space in the pool. Make sense? It's simple, it's easy, it's transparent, and therefore that's good. You can be more efficient. So let me show you a quick demonstration of what this looks like. And forgive it's going to get a little fuzzy here, but it's better to see it this way than it is to kind of see just a slide. So what we've got here is we've got a vSphere 5 environment. It's going against the VNX. Do we have any VNX customers in the room? Okay, thank you. So as I go in here to vSphere, you can see that we've got a device, right? This pool 1 that's 8 terabytes in size, of which it's using 72 gigs of space today, right? Again, big ones are becoming much more standard model. Big data stores, simplifies management. NFS big data stores as well. So if I go in here, you can see it's consuming roughly around 70 gigs there at the VMware layer, right? Because this is the same thing, looking at a vCenter and a storage layer. So in this case, what we had done is we created this VM on that data store, and it didn't use a lot of space because it was thin at the VMware layer, thin at the storage layer. And then we did a DD. We basically filled it up with data, right? We did a snapshot beforehand. It's not just deleting VMs that deletes these files, deleting snapshots frees it up too. Deleting stuff also in guests can help sometimes. So basically what I'm doing is I'm reverting back to the earlier point of view of this VM before we filled it all up. And then I'm going to delete the snapshot itself, which actually will delete the file of the VMFS layer, right? Previously, you go back in and you see that the storage consumption of the storage layer was still 70 gigs being used. Make sense? So if you go and you take a look, notice immediately in vCenter it goes, hey, it's now only 3 gigs used, right? And now I'm going to pop over into Unisphere. Simple, easy, vCenter integrated. One of the only arrays that integrates with VMware and vCenter from the bottom up. If you take a look, the storage usage again here is about 2 gigs. If we pop over, we'll see that on the Unisphere side, it's currently showing slightly more. So if you take a look at that individual data store, you can see it says 8 gigs used. Remember before it was 70? But then watch this. It'll eventually just pop down in a moment to 6. So that the reclaim is slightly asynchronous, right? But again, notice the space got reclaimed. Exactly or what? Simple, easy, and good. Next, NFS full file copy. We now have NFS hardware assists. So this one here, previously when you wanted to clone or deploy, is that when you use NFS-based data stores? You should use them together. They're very useful. It would read and write the file using the network, the VM kernel for the NFS export all non-stop. And with the API, what happens instead is it says, hey, let's clone the VM, and off it goes, right? Way less bandwidth. So I'm going to skip this demo in the spirit of time, right? Because there's lots and lots of stuff, and I guarantee I'm going to run over schedule. But I'm going to post it online, so does anyone here read Virtual Geek? If you do, check it out. You can watch the video and see how it works. It's also awesome. Now, the one thing that is worth pointing out is it still creates a full copy of the file. In other words, there's still all the heavy lifting of copying all the data from one place to another. It doesn't use a file with a snapshot. That's on our implementation. That's because it's called NFS full copy. So the inevitable question is there an NFS fast copy? Well, it didn't make it quite, but we're working on it. As part of the VAI spec. So think about that for going forward. The other one is this idea of extended stats. The problem was that NFS-based data stores, the VMware host would have no idea how much space is actually used, right? Because the data was on the NFS server. Unlike with VMFS, where it controls the file system, it doesn't control the file system. So what used to happen is it would say, how big is the file? And it would say, it is 100 gigs in size. The reality is, wouldn't it be better if it said, hey, the file looks like it's 100 gig, but it's a sparse file, meaning it's thin, so only 24 gigs is actually allocated. And by the way, the file system is deduped and compressed, and therefore it's only really using 5 gigs. That would be a much better answer. Right? You could have a nice vCenter view of that. And the one thing that's worth noting is this didn't make it into the VC client, right? So again, we supported the storage subsystem layer, but it didn't quite make it into the vCenter layer. So think of it as a mystery assist to show up in future releases, undisclosed date or time. NFS reserve space did make it, was very useful, which is previously you had no way of saying reserve the space for this file. I'm going to force you, already do it. Now why would you want to do that? Microsoft clusters demand it. So again, there's easier ways to do clustering, but sometimes you've got to deploy Microsoft clustering, array services for clustering in your versions. So if you have an array that supports this, which EMC arrays do, you get this option where you can say, you make it flat, make it flat, initialized, or completely provisioned and thick, which previously you couldn't do on NFS, which meant that you could never have Microsoft clusters running on NFS data stores. Make sense? This is one of the things that's required to make clusters work, so again, stay tuned on that front. Okay, vCenter plugins matter a lot. Does anyone here use the EMC vCenter plugin, VSI? Okay, geez. Okay, someone who raised your hand, brave soul. Is it good? Does it help you?
Yeah, we deploy it for all the customers, and none of our customers are using Unisphere anymore. They just use plugins.
So, anyone else?
That's awesome.
So,
10 times easier.
10 times easier. That's what I'm looking for. Fantastic. There's another one. So by the way, I can see why not everyone's using this because it costs a lot of money, right? It's free. It's free. If you're using EMC arrays in vCenter, to not use this, you're high. Something's wrong with you. You're like the guy who was in the hallway this morning when I left my room, lying down. He had his cell phone there with him, Rachel sleeping on the floor. Man, some people just can't pace themselves. So, the good news is VSI, or Virtual Storage Integrator, is now on version 5. G8, now. So, this supports vSphere 5. It does all sorts of cool stuff. The thing is that we're continuing to evolve down this path. The first one just gave you visibility. The next generation lets you do provisioning. The third generation lets you kind of merge these together. We used to have lots of different plugins, one for VMax, one for VNX, and we merged all that stuff to simplify it. Fourth generation, we started to hear some complaints from customers. And the complaint was, hey look, I'm the storage dude, he's the VMware dude, I have to give him the credentials to my array to let him do this stuff. That's a little scary for me, right? And what happens if he mucks up something that's another thing that's not related to VMware for bigger customers, right? So we started to do some initial roles-based access controls. In the 5th generation, we added a lot of stuff, but we also made this use case awesome. So I'm going to show you what this looks like. Red screen means I'm a storage admin, right? So the storage admin goes in and says, and again, this is something that's available now. I'm going to go in and I'm going to say, I'm going to give my VMware admin a delegated access to be able to do what they want within the storage array. I'm going to create a profile for this, right? The profile, I'll call it VNX01. You can give it a description if you wanted. So fantastic. And again, the purpose of this is to get delegation without making things complicated. So the delegation is good because frankly it makes the life of the VMware admin 10 times easier and faster. But without this sort of deep roles-based access control, it can be very dangerous, right? So now what you can do is you can say, what arrays would you like to add access to this? So here, as I say add, you'll see a series of choices. So do you want it to be a Solera, a Clarion, a VNX, or a VNXE? If you have does anyone out here have a VMax? There's even a richer version of this called Storage Pool Manager. So again, the smallest of the small to the biggest of the big, deep roles-based access control. You can say block and file, one or the other, both, right? Here you go. And then you can say, do I want to give the whole array, no pools, which would just give them visibility, or a specific pool of storage, this set, right? So we'll pick a selected pool of storage. And you can see here there's a series of pools that have been created by the storage engine. So an example here is we could go and say this gold, fast, or fully automated storage tier, let's enable that one, right? Okay, great. You go in and we say, do we want to add any more arrays? You could actually, if you have 10 arrays, you can just build a little profile package that you give to the VMware admin. And at the end of the process, you're going to export that, and you're pretty well done. So as it gets exported out, we're now going to put it in a place where you say, here's your little profile VMware team, go at it. So now I'm going to switch over at the end of this to the VMware admin's worldview, right? So we're saving it to a share to VMware team. Off they go. How many of you are the storage admin and the VMware admin? How many of the VMware admin and have a storage admin? Right. So again, we need to cover each one of these use cases, right? So off it goes. You give it a thing that will later be used to decrypt the file. It's not actually the credentials to the array. So now we switch over to the VMware admin's worldview. VMware admin worldview says, hey, I just got this thing. If I open it, notice it's encrypted, right? So none of the credentials are sent there in clear text, right? So that's, again, a problem. If you don't do this, man, your vCenter plugin model is a little bit busted, right? You got a bit of a security hole. So now if you go to VSI, which is in vCenter, right? This is home to the VMware admin. VSI is our plugin. You can go in and you can say, I'd like to import an access profile that's been given to me by my storage team. If I happen to be the storage team, people raised their hand earlier, you can just go, man, give me the credentials, I'll just go in and I got it, right? So here they just imported it, and now if we go in and we take a look, notice the provisioning access is restricted. All I can do is my pool. I can't screw up anything outside that pool. And now if we go in and do a common use case, like provision a data store, right? And I say, all right, I want to go and do this. By the way, that set multipathing policy will automate setting up multipathing across clusters. So you don't need to go in and manually configure that stuff. So hey, that's awesome. Now notice that it says here's the array that you're allowed to use, and when I go in and I say where do I want to create the data store, it says, by the way, that's the only pool that you're allowed to access. It doesn't show me the other ones that exist, right? So again, I'm seeing only what I'm allowed to delegate and do provisioning with it. And then once you subsequently say, yep, we're going to create a data store here, when you go and you take a look, you can say VMFS 5. VMFS 5 will automatically have an allocation size set of 1 megabyte, which is the default. And then you give it a name. You could set up RDMs this way if you want to, but generally, RDMs are create management complexity. We don't recommend that you use them. Had we said NFS, you could have gone in and created an NFS data store, unified storage. It doesn't matter to us what protocol you use. And then you basically here, since we're doing VMFS, you give it a LUN number, you give it a capacity, right? I'll do it in this case, 8 terabytes. We'll make it thin. If I click on advanced, you can see auto-tiering policy and compression and other stuff like that, and boom, done. Now what it's doing is it's actually provisioning that underlying data store on the VNX, and it's actually presenting it across all the nodes in the cluster. Simple, easy, efficient. Make sense? So, what I'd say is, like, holy smokes, did I mention that this was free? If you're a VMware and EMC customer, to not take advantage of this, you're just missing out. Right? It's awesome stuff, it's very robust, customer feedback is great. I've never encountered a customer that doesn't say, it's great. Sometimes they give us feedback about what we can make better. If you're a customer using it, I'd love to hear it. But I think we've gone way out ahead of this, and if we do this little test of how is an EMC doing against all of these things that you could do, we get best of breed check marks on all of these. No one is more integrated with VMware than EMC. The one that I didn't check was VM object awareness inside the array, which is weird because we do it. In fact, we're the only major storage vendor to do this today. Whether you're using a VNX, VNXE, or VMAX, their UIs natively connect to vCenter, so you can see this VM is running on this thing within the UI itself, the storage UI. So why didn't I give us a check? It's because the array kind of knows the relationship, but doesn't speak in VM objects. Did anyone go to VSP3205? Was it cool? Yell it out, man.
Yo!
Yo! It was cool. I'm not allowed to talk about it. And you see the EMC demonstration in there. Right? Hey, yeah, you know it. So what we're doing here is a really cool technology preview of what's coming in the future. In the future, storage subsystems will natively speak and interact in VM object terms, which means that you'll be able to replicate and snapshot VMs. There won't really be LUN and file system constructs per se that you'll see. The management problem is dramatically easier, and we can do crazy things like having a data store, not a data store, because the data store doesn't exist, a storage pool. Be able to go, yeah, I could create a VM that would be fast, I could create one that was compressed, this one could be snapshotted. Today, those all have to be put inside a data store that does that. In the future, you'll just be able to do it, the VM will do it. So I gave us a yellow, I'm a harsh judge. We do VMware integration on this point better than anyone today, but again, that session talks about where we're going next, which is really cool. So, what's been the fundamental near-term effect on storage models for VMware use cases? So, storage architectures in VMware, again, every vendor makes an argument that their architecture is fundamentally better than everybody else's. Because, of course, we're all in the business of trying to service you guys as customers. If you take a look at it more broadly, like from an engineering perspective and a vendor-neutral way, there's fundamentally several different architectures about how to build a storage array. The first one looks like this, kind of two brains in a classic cluster with disks behind it, right? This would be like a VNX array in EMC land, or a classic NetApp, kind of FAS cluster, right? Or an EVA if you're an HPE customer, right? You can think of the examples, right? These, the way it works is as you interact via vCloud Director or vSphere, right? And as you add more hosts, you add more disks, but there would come a certain point where you need to buy another one, right? Because the ports, the brains would start to get filled up. Does that make sense? I'm going to call this a type 1, right? The other type is a different one. And notice how I said that one can be SAN or NAS today, and this one is more SAN today with NAS emerging. is that as you add nodes, you add disks, but as you need more, you scale out horizontally by adding more brains and ports. Anyone want to yell out an example of this? Isilon would be one. What's another one? 3PAR would be an example like this.
VMax.
Equal logic would be an example like this. Right? Left hand would be an example like this. VMax would be an example like this. Now again, that doesn't mean that they're all the same. They have massively different capabilities, right? You know, but architecturally, it's a different way of building a storage subsystem. Does it make sense? So why did I say SAN today and NAS emerging? I'll explain why in a moment. There's this other third category of storage which is related to cloud, which is very weird. Does anyone here use Twitter? Everybody? Anyone use Facebook? Come on, seriously, you're not cool. Always use more friends. eBay, anyone? eBay ingests, millions of objects every day. People posting, their ads and stuff like that. All of those examples are places where people are not using transactional storage. It doesn't need response times in milliseconds, right? Today, that is generally deployed on stuff that's very loosely coupled storage models. So, and it's usually presented up as objects via RESTful APIs. Right? So this is stuff where response times are kind of in like many tens of milliseconds to hundreds of milliseconds. But that's fine when you're building a web page or a picture. Right? It's not fine if it's a database or if it's a VMDK. Right? But these things are very interesting. Can anyone shout an example of these things? Atmos is one of the EMC major product that does this. Amazon S3 works like this. Right, so there's a smaller set of examples, but believe it or not, these types of storage models almost currently consume and store more data globally than the stuff on the left, the more traditional models, just because of consumers doing stuff. Right? Now they're very loosely coupled. So if you think about this, type 1 tends to be simpler and lower cost and be very feature-rich. Swiss Army knives. They can do lots, right? Type 2 tends to be lower cost and simpler at scale. Once you get to a certain point, these scale-out models are nice. But it's hard with NAS. It's hard with NAS because 3PAR, VMax, those examples use tightly coupled models to have cache that's very tightly integrated. Any I/O can be serviced by any port, which means that scaling up very wide is hard. It's very hard for us to go from 8 engines to 16 engines to 32 engines. Same thing for everybody else in that space. NAS, on the other hand, Isilon is the leading example in this, has latencies that are about 2 to 3 times higher, for a single I/O. You can think of an I/O on a type 1 or a block type 2 to be, 5 to 10 milliseconds, and NAS on a type 1, 5 to 10 milliseconds. On a type 2 NAS, whether it's SONAS from IBM, Isilon, those sorts of things, you're talking more like 10, 20, 30, 40 milliseconds. Not as high latency as the very loosely coupled systems would work. Does that make sense? But the scale of NAS use case is interesting. So, I'll get to that in a second. So what we did, with the vSphere 5 release, we wanted to push the boundaries of performance limits. So the first one is about, a month ago, this VMware performance engineering team, EMC performance engineering team gets together and go, what are going to be the cool things we'll talk about VMware, breaking records and stuff like that. So first one we said, hey, let's break the 10 gigabyte per second barrier. That's 80 gigabits per second through a single storage array using vSphere 5. So how do you do that? Well, you get vSphere 5. You get 4 moderate kind of servers. We use the Intel X520 NICs. These are NICs that don't have a custom ASIC for FCOE, and then we use the software FCOE initiator in vSphere 5, which is kind of cool. It was one of the first big tests with this, which was kind of neat. Then you get a type 1 transactional system, the thing on the right, and that can leverage lots of multi-core, it can use flash, it can do all that stuff and drive a lot of bandwidth. Put engineering teams in a room, let, stir and let mix, right? And what you end up with is this. We set the record, we broke it, we drove more than 10 gigabytes per second, and it was basically about 3 to 4 times faster than the previous record that we had set ourselves, but using 1/3 of the number of arrays. So it highlights lots and lots of progress. The other idea that we had was, let's break the IOPS record. The previous record was also held by us, 350,000 IOPS rough and tough. So again, vSphere 5. Now in this case, you want a monster server. right? Because this is all about cores, in the individual system. The other one was around bandwidth, how, PCIe buses and stuff like that. So there's no network bottleneck. Get a Type 2 system, because here we need lots and lots of front-end brains, right? And very low latency. Again, engineering team, let's sit. What was the monster server? It was a 40-core Intel E7-based, Westmere-based CPU, which on that one server had 96 gigahertz of processing power and had 120 megabytes of RAID 3 cache. Wow! Right? So this is this is not your normal kind of configuration, but we're having fun. This is the fun part of the job, right? This is what the VMAX array looked like. The VMAX, the marketing team was like, Chad, you cannot show that picture. It's missing the cool faceplates, and the cool, Cylon light on the front of the array. And I'm like, look, it's a nerdy audience. They'll dig it. But basically, this is 8 engines, right? Which is basically 16 sets of brains in a scaled-out cluster. It's a lot of horsepower. Under the full load, that VMAX looked like this as a heat map. So there's 128 front-end ports, 8 engines, front-end, back-end, 128 ports, 160 drives. Yellow is the brains were not working that hard, right? They were kind of in the middle. They were breaking a sweat, but still kind of, I got some oomph in me. The disks look all hot, but actually all they're doing is keeping the cache warm, right? But this was out of the box, vSphere 5 and a VMAX basically broke 1 million IOPS. No fancy tweaks or optimizations, which I think is cool. What do you guys think? Cool?
Yeah.
Cool. The analysts always come up to me and go, well, is that a reasonable workload? Or what kind of... No, it's totally redonkulous. Right? No one uses a workload like this. Right? Well, some people do, but it's very, very rare. The point of the exercise is A, to have a little bit of fun, because it is fun. Find bottlenecks in the system, but also prove to you guys as the customers, again, who is virtualizing SAP? Why aren't you all raising your hands if you're an SAP customer? Oracle. Right? Again, the pattern here is people have fears that aren't actually rooted in technical reality. And so by showing that the workload limits are so far out of the realm of a mortal workload, we can kind of say, do it with confidence. Okay, this has been posted online. You can see it from the VMware Vroom Performance Engineering team, which is a really cool blog. I highly encourage you to take a look at. Next, what about scale-out NAS in the VM? Wouldn't that be kind of cool? Who thinks it would be cool? Well, I think it would be cool. So, I'm going to show you something that I think is really cool. NAS in vSphere uses NFS v3, right? The problem with NFS v3 is a single TCP connection is used for a single NFS export, which means on classic Type 1 NAS models, all of the exports go to a brain, right? Which means that if you ever have a failure, it fails over to the other brain, right? So there's a failover behavior, and the workload isn't balanced. You have to constantly be trying to balance what brain is doing what, right? So that hasn't changed in vSphere 5. It's not going to change until future vSphere releases. But what did change is you can use DNS round robin. And I'll show you why that's important. What we've got here is we've got 4 vSphere 5 hosts, right? You can see them there. And if you go and you take a look, this is a slightly, pre-GA, but it's vSphere 5, right? RTM bits. So if you go in and you take a look, we've got a single VM here provisioned. And we're going to add an NFS data store that's presented by an Isilon cluster. Isilon can scale out to 144 nodes, right? So a huge scale-out file system model. And very uniquely, what it does is the file system can be spread out across all the nodes. It's not a global file system. It's better. Global file system is the file system exists on this node or this node, and then there's something that makes it look like it's distributed. Here, the file system actually is planned out across all the nodes as you add it. So here, as I add this data store, it's using NFS v3. So as I go into the Isilon UI, what you'll see is a single connection being established from this ESX host to a single node in the Isilon cluster. You can see roughly call it 18 terabytes of usable capacity, and boom, there it is. We now have one connection. This ESX host has made a TCP connection to mount that data store. Makes sense, right? So as we go in now and we say, okay, great, now let's add a couple more data stores, to make this interesting. So we'll go in, we'll add a few more. What do you guys think will happen? Remember, we're doing this on a single ESX host. Will they go to one node or the other node? Because remember, there's 3 Isilon nodes in the cluster right now. Anyone want to take a wager? Wager? Well, previously, if you used an IP address, it always would have gone to 1. Now we're using DNS round robin. So it's going to a single, it's a DNS name of the array, not, the IP address, which means it's actually going to create a new TCP connection for the second data store to another node inside the Isilon cluster. Make sense? So, hey, hallelujah, there you go, right? So, if we did this again, you kind of continue to see this pattern where one after another, the workload would start to become distributed. And this is a beautiful thing. That's my 10-minute warning, right? 10-minute warning. Roger. Uh-oh. Okay, flying horses. So, the idea here, is that it's good to distribute these workloads because it means that there's much less risk of a single failure affecting a lot of things, and you're balancing the workload around things. This is the benefit of type 2 models. So, as we create that third one manually, no big surprise, this third one will be connected to a third node. This is changed from vSphere 4 and 4.1 to vSphere 5, which is great. Now, we had a single ESX host in this example, and then we had, a lot of them. So let's speed up this process. So, what we did with that plugin? We created a little Isilon extension to our VSI plugin. So what I'm going to do now is we're going to go in and say, let's speed this up, and across all 4 nodes in the cluster, let's create 5 data stores on all of them. So now we have 20 mounted NFS exports. Make sense? Remember, 3 Isilon nodes in the back, 3 brains, right? So as we go in, we're going to say, okay, there's an existing data store that's been created. This is the Smart Connect zone, and then here are the data stores that exist. Those NFS exports, boom, 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 and off we go. So what's going to occur? Very rapidly, you'll see the NFS connection count go up across those 3 nodes. Again, simple and easy. Notice I'm actually not configuring multipathing or load distribution. It's just naturally balancing across the cluster. Right? And simple is good. Simple is smart, as the Isilon folks say. And you can see, boom, it's raised up. Okay, great. And nice and balanced. Now, this on its own would not be that cool. Right? So we said, okay, let's make it even more cool. Let's now start to add nodes to the Isilon cluster. Right? I now need more storage. I need now more processing power, more bandwidth. So let's go in and say, we're going to go from 3 nodes in the cluster to 10 nodes. That's going to be hard, right? Quick, quick. So it's really, really easy to go in and say, we're going to add nodes. You get this little pop-up window that says, here are the available nodes that you can add into the Isilon cluster. And you can't, I don't know, where would I click to add a node? Probably the add node button, right? So notice the 5 data stores are there, right? These are the same 5 data stores we're talking about. Those 7 nodes that we're adding don't have any data on them right now, right? They're just sitting there kind of idle. The file system is sitting across these 3 nodes over here, right? So what I'm going to go in, I'm going to say, let's add each one of these nodes into the underlying cluster. Now, the thing that's really unique about Isilon, and one of the reasons why we've got to have that technology, as you can see, it's so cool, is that the file system, when you add the nodes, starts to go and get spread across all the nodes that you add, right? What that means is that you get all a better resiliency and scale and performance. It's better than a global namespace because it's completely a single namespace, a single file system across all the nodes in the cluster. So what do you think is going to happen here with those 20 NFS TCP/IP connections, right? Well, take a look. So as these things are all, by the way, that was real time. That's how long it takes to grow a cluster. So notice that we've now scaled the cluster, but we still only have all of the connections listed there, all going to 3 nodes, right? It's because on Isilon you can say, I want this file system to be able to go out on all of these ports or just on some of them. So what we're going to do, and by the way, notice file system size just grew automatically, right? So, to be able to redistribute the workload, what I need to do is extend out the pool of interfaces on which those exports are made, right? So if I go back into the Isilon UI, and I go and I say, all right, let's expand out the Smart Connect, zone, right? And add all of the additional interfaces out of those 10 nodes that I did. Let's see what happens. So boom, here we go. You can see that, there's pooled members down there. There are nodes, and each node has got an interface. So let's go ahead and say, let's edit this. These file systems, they're all using 10 gigabit Ethernet. So let's, add all of these extra interfaces to these NFS exports. Make sense? Again, this is a longer demonstration. You'll see where I'm going, right? So if we go back, this is where it starts to just get crazy awesome, in my opinion, right? Notice that the workload, all of the TCP connections, automatically went out to all of the other nodes without me needing to do a thing. That means that literally I'm just going boom, 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 and adding storage nodes, and the vSphere 5 NFS behavior with an Isilon cluster will just start to consume all of that extra stuff. Like, that is, how easy is that? That is easy, right? So then what we did is we said, okay, now let's really show how this works, because we're nerds. Nerds. So what we said is, let's clone a whole bunch of VMs on that data store, and then let's actually start to create some workload against them and see how the workload gets distributed. So, boom, all these VMs have now been created. Now let's kick off a workload. Each one of these is doing like an ionometer workload inside the VM. And you can see the cloning operations are all cooking along, right? By the way, the thing that's interesting is already the workload is balanced across all the nodes in the cluster. And off it goes. Okay, great. All the VMs are up and running. This is the same sort of crazy automation that allows us to power the hands-on labs, which obviously are brought to you by VMware, but happily supported by EMC, running on a lot of VNX here, as well as other VMware partners. But I'd encourage you to go check out the hands-on lab. It's very, very cool. So here we're going to do is fire off that workload generator, and let's see what's going on from a bandwidth standpoint, right? So if you take a look at it, of course, what's going on? The bandwidth is completely evenly distributed. And once you take a look at it from within the Isilon cluster configuration, you can basically see that the workload is perfectly balanced. We're already driving on this cluster. If we go over and take a look at the Isilon UI, right? We're driving basically, notice it's about the same in each one of the examples of how many megabits per second are being driven. We're currently driving 12 gigabits per second worth of bandwidth across these 10 nodes. Simple, easy, boom, like that, right? Now, I'm going to run out of time, so I'm going to skip this last thing, unless you guys want me to do it. Do you want me to do it?
Yeah.
So the next part that I thought was cool, we said, hey, let's do the Penn and Teller thing of pulling out a gun and shoot one, right? So we're going to just take a node out. So basically we're issuing a command that says, this node has failed, right? So when we fail this node, the interesting thing is what's going to happen. There's no failover. All that happens is that it's a TCP reconnection. So what occurs is that one goes dead. You'll see that the client connection summary, gets refreshed and then goes down. And then if we go and we take a look in the vSphere layer, right? All the NFS connections have moved to the active node. That one is sitting dead. We lost a little bit of bandwidth through the process, but it's still whole and healthy. This is this is the resiliency model of type 2 block, but deployed with the simplicity model of type 2 NAS. Does that make sense? But again, we'll only work with an Isilon-style approach to this, where the file system actually exists on all the nodes, not just redirection, right? So what do you think? Is that cool or what?
Woo!
By the way, so the thing that I would highlight is, remember what I said earlier, type 2 NAS still has higher latency behaviors, right? So just, it's not the right thing for all use cases. Most use cases are still better served via VNX type use cases today, but if you have tier 2, tier 3, tier 4, kind of VMs, I/O, latency, and response time, it can be a great, great fit. But imagine if we could actually make that work well with really high I/O transaction rates. That would be cool, huh? Okay. Last thing. What's going on longer term in storage? The line between compute and storage is becoming blurred. Flash will live everywhere, on the server, on the storage, as a cache, as a tier. Data is going to move closer to compute, and compute is also going to move closer to data. And distance gets blurry. So let's talk about the last one first, distance getting blurry. We're doing a session on this topic, right, about disaster avoidance, disaster recovery. People want to blend these ideas. So vPlex allows you to basically have an active-active storage model across distances. It's very important for stretched clusters today. We're holding a session on this, which I'd encourage you if you're interested in this topic of stretched cluster use case, geographically dispersed cluster. Check out that session. It's going on 4 today. It's repeating again tomorrow. VMware and I are co-presenting. The last thing I'm going to mention, very briefly, and I've got a cool demo that will run out of time, so I'm not going to do it, is storage compute mashups. Right? Has anyone seen any cool startups around there about like you can run VMs on the storage, and mixed compute, and maybe you could run the storage as a VM on the server, like the VSA. Those are important ideas. They have logical uses both today and tomorrow. So our view is that sometimes compute workloads access huge data sets. When they do, it actually makes more sense to run the workload on the storage subsystem, the compute workload. Right? It's easier to move the compute than it is to move the data. And a VMax is a bunch of Westmere-based CPUs, right? Sitting in a large memory configuration, right? An Isilon cluster can be up to 144 servers. That would be a really big vSphere cluster, right? And then if the software is running as a VM, it means that you can run VM workloads directly on the storage subsystem. We demonstrated this in a video in the keynote, in Pat's keynote. And if you go again on Virtual Geek, you'll see the thing that I won't be having a lot of time to demo. But the other thing is that there's going to be some workloads where the data set is small, but very transactional. And in those cases, the idea of server-side flash is very, very important. Because PCIe-based flash or SSDs on the server can be very, very low latency. Right? Again, there's people out there that argue it's one or the other. It's not. It's not. It's going to be both. Right? Different use cases have different needs. At EMC, we've got a project called Project Lightning. This is by the way, we actually have some stuff working on Project Lightning cards here at the event. You're not allowed to see or touch. This is one of the Gen 1 prototypes. The Gen 2 cards are half-height cards, but basically this is a PCIe-based flash card. And what we demonstrated in Pat's keynote is that we've also started to build in VM integration. So within vCenter, you can enable this card for a VM, so VM-level object awareness. Our view on this is that ultimately people want their data to be able to figure out, hey, where should I do it? Should I use fast on the array? Should I tier this so that it's actually on the server on one of these things? And then the big problem with these things is they're not shared. So if the data in here is awesome, but this server over here has another one of these, but it doesn't have that. It doesn't matter if all of a sudden it needs that information, right? What would be cool is if you could build a cluster and have the cache existing in a coherent fashion across all the nodes. Right? Does that make sense? So these ideas of mashups, again, I will run out of time, so I'm going to skip the demo. But basically, we're absolutely thinking that these models are important. We demonstrated the ability to run VMs on an Isilon cluster. We talked about doing it with VMaxes. Project Lightning, our target is to GA that before the end of the year. So I'm going to skip that. Solutions Exchange, there's EMC booth and interactive demos there. If you haven't been following it, if you go #vhunt, you can win prizes by doing stupid, silly stunts. And then after VMworld, there's this great community. The thing I would really call out is we have every EMC product running as a virtual machine in the EMC lab. If you want to try a VMax, try an Isilon, try a vPlex, try an Avamar, try an RSA, try it. They're all there, right? And who knows, if you buy the guys a cocktail, maybe they'll give it to you on a USB stick. What do you say, Chris? No? No? Listen, thank you so much.